welcome to Chemical Wisdom. So this is the third part of this series on chemical bonding. In the previous video we discussed electrovalent bond, and now we're going to be looking at covalent bond. So it's a bond between two non-metal atoms. So what happens in covalent bonding is that instead of atoms transferring electrons, they actually share the electrons equally. So there's an equal sharing of electrons between two atoms, and in the process they obtain a stable electronic configuration or a stable state, in that the valence shell becomes completely filled with electrons. We're going to be looking at that in the subsequent examples. So when one pair of electrons is being shared, is represented by a single line. Single line represents that only two electrons are shared. So when two pairs are being shared, either 4 electrons are shared in the process of covalent bonding, is represented by 2 lines. Don't worry, you will see that in the examples. When 3 pairs are being shared, it's represented by 3 lines. So 1 line shows that 1 pair of electrons is being shared, 2 lines shows that 2 pairs are being shared, and 3 lines shows that 3 pairs are being shared. So a typical example of covalent bond is the bond between 2 chlorine atoms. So we have the first chlorine atom and the second chlorine atom. So this is a structure for the first chlorine atom. It has 7 valence electrons. Can count 1, 2, 3, 4, 5, 6, and 7. Second chlorine atom has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So these two atoms need only a single electron to get their valence shell filled up. So the chlorine is a non-metal. It can't transfer, unlike metals that will just transfer the valence electron. But it's electronegative in that it can only gain or share electrons. That's why this structure forms now. The two of them combine together, sharing this electron. This one will share this electron with this other one. That's why we have this structure. These 2 electrons come together like this. It is being shared equally. So this forms an entirely new structure, in that the valence shell of this first chlorine atom becomes filled up, and the valence shell of this second chlorine atom becomes filled up. For example, if you count now, you see that it's 1, 2, 3, 4, 5, 6, 7, 8 is now completely filled up. That's why this first chlorine atom now is balanced, and the second chlorine atom now has 1, 2, 3, 4, 5, 6, 7, 8. The second chlorine atom now is balanced. So that's how atoms combine covalently, in that they just share the electrons. They don't transfer. There's no transfer, there's no gaining, only equal sharing in covalent bond. Okay, let me show another example. So because only 1 pair is being shared, you see this 1 pair. 1 pair means 2 electrons are shared. That's why the diagram of the molecule of chlorine has only a single line linking the 2 atoms. This single line represents that is only a pair of electrons being shared. Let me show you the example in oxygen that has 2 lines. So if we look at the structure of oxygen now, covalent bond in oxygen molecule, this is the first oxygen atom and the second oxygen atom. The first one has 6 valence electrons. Can count 1, 2, 3, 4, 5, 6. And the second atom has 6 valence electrons. We have 1, 2, 3, 4, 5, 6. So how would these 2 now combine to form a stable electronic configuration, in that the valence shell becomes filled up? They share these 2 electrons. They are going to be sharing these 2 electrons. This one will combine with this. This one will combine with this, and this one will combine with this. I see the link. That's what happens here. This is the first pair, this first pair, and this is the second pair. These 2 guys, that's what forms the pair. So you can see there are 2 pairs of electrons being shared by these atoms equally. So you can now count, and you find out that this first oxygen atom has 1, 2, 3, 4, 5, 6, 7, 8 is completely filled up, and the second atom has 1, 2, 3, 4, 5, 6, 7, 8 is completely filled up. So that sharing process makes it possible for their valence shell to be completely filled up with electrons, and they thereby obtain that stable state. They are not like rare gases. They are not like noble gases. So this oxygen molecule now is not reactive, in that the atoms are stable. So that's why is represented by two lines. The first line represents the first pair. The second line represents the second pair. So let me show you another example whereby 3 pairs of electrons are being shared. For example, in the molecule of nitrogen. We look at a nitrogen molecule. It has 2 atoms of nitrogen coming together. So we have the first atom and the second atom. Nitrogen has 5 valence electrons. You can count 1, 2, 3, 4, 5. Second atom has 1, 2, 3, 4, 5. So what happens in bond formation, in their covalent bond formation? This first electron pairs up with this electron. This electron pairs up with this electron. So you have this one pairing with this one. You have this one pairing with this one. And you have this other one pairing with this. That's why we have 3 pairs of electrons in a nitrogen molecule. We have this, the first pair, these 2. The second pair, these 2. We have the third pair, which is these 2. So that's why nitrogen molecule is represented with 3 lines. The first line represents the first pair, the second line represents the second pair, and the third line represents the third pair. So that's basically how covalent bonds are formed. In that 2 atoms come together, they are non-metals. Because they are non-metals, they are electronegative. They would rather accept electrons or share it. So you can say they are stingy, they are greedy people. So they would rather accept or share rather than giving out. They are not givers. They are not givers. So that's why they share electrons equally. If you count the number of electrons now in the valence shell of this nitrogen, the first nitrogen atom, it now has 1, 2, 3, 4, 5, 6, 7, 8. The valence shell is filled up. Look at the second valence shell. 1, 2, 3, 4, 5, 6, 7, 8. That one too is also filled up. So that's what happens in covalent bonding. We have 2 atoms, 2 non-metals coming in together to share their valence electrons to obtain a stable electronic configuration. So please, if you like this video, please make sure to hit the like button and don't forget to subscribe and click on the bell icon so as to get notifications on the release of new videos, because we are going to continue running the series. The next one on the series is the dative bonding. It still deals with sharing of electrons, but it's quite different from the covalent bond. So please make sure to subscribe. Make sure to subscribe.